and then ask me questions. All right, here we go. It says use 5 rectangles of equal width to find an approximation area of the region lying between the graph of f of x equals negative x squared plus 5 and the x-axis between x equals 0 and 2. Okay, so let's draw a picture. So here is my grid. I'm going to exaggerate quadrant 1. And negative x squared plus 5 between 0 and 2, well, 2 squared is 4. Negative 4 plus 5 is 1. So I'm going to say that 5 is like up here. And I'm going to say 1 is like right there. So it probably looks something like, and of course, look, I'm exaggerating, right? So I'm going to say that 2's right here. Obviously, my scale is so off. Not a big deal. Boom. Did they tell me how many rectangles to use? Dang. Oh, this is 5? Okay. 5 equal rectangles. So n equals 5. So I need to figure out the delta x of each one of these rectangles. So I'm going to write delta x equals 2 minus 0 divided by 5. Upper minus lower divided by 5. This is the 2, and then this is the 0, right? So my delta x is 2/5. So let me see if I can draw 2. I'm going to say that one is 2/5. 4/5. I'm just adding 2/5 to the every time. 6/5. 8/5. And then this 2 is 10/5. That's an equal sign. It's just upside down equal sign. Or sideways equal sign. Are we still okay, guys? All right. They want me to use RRAM. So here we go. Between 0 and 2/5, put a point on the curve and go. It actually, there we go. Because it's decreasing. So it should be below it. Trying to draw the best I can. I suck at drawing. Here's my third. The fourth. And the 5th. So it's not perfect, but that's fine. Nothing crazy, right? Okay. Let's find this area of these rectangles, and then we'll talk about how to use summation notation, because that's what they want, I think. Maybe I didn't type it in there. Let's draw. We can come up. Yeah, let's even come up with a formula using sigma notation. So let's not do that yet. Let's just find the area of this. So width times height. So every single rectangle here, this is n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. It's just for reference. So the width of the first rectangle is 2/5. And then the height of the rectangle, what's the height? Was dictated by the curve. So it's dictated by negative, well, not negative. Put the negative on the outside because it says negative x squared. Negative on the outside, 2/5, close it, squared, plus 5, close it. That's going to be the height of the first rectangle for n equals 1. So I'll go ahead and put this as n equals 1 plus 2/5, open parenthesis, negative on the outside, 4/5 squared plus 5. Do you guys know what I'm doing? No? Okay, I'll stop. Let's do. I am doing width times height. The width of each one of these rectangles is how much? 2/5. And the height is determined by this curve. And that curve has a function or a model of negative x squared plus 5. So how do I find the height of my first rectangle? N equals 1. Plug in what value in for x? Yeah, 2/5. See, so negative 2/5 squared plus 5, which is that function. And this will give me my height. width times height. And then there it is. That one over there is for n equals 2. So this one here is n equals 2. All right, keep going. Plus, again, I have another 2/5, giant parenthesis, negative in the front. The third rectangle is dictated by the x value of 6/5. So I plug in 6/5 into that model or that function, plus 5 to give me that y value, plus 2/5, parenthesis, negative on the outside, 8/5, close it, squared, plus 5, close it, plus the very last one here. I know that I could write 2 guys, but I'm going to write 10/5 because we're going to come up with a pattern in a little bit, if we can. Does that make sense to you? Okay, let me go ahead and put a n equals 3 here, n equals 4, n equals 5. What do each of these quote-unquote terms have in common? A 2/5. Yeah, I guess you can also say the plus 5, but we're not going to worry about that. So I'm going to factor out my 2/5. I'm just going to go, I'm going to figure out what this is. N equals 1. Well, yeah, I already said it, so let's just do it. Negative 2/5 squared plus 5. You know what? I'm going to do it like this. Y equals negative x squared plus 5. And I'm going to come here and I'm going to go alpha trace y1, and I'm going to type in 2/5. 4.84. I keep doing that for all of them, right? So let me go ahead and just start all of them. I'm just putting in y1 of 2/5 plus alpha trace y1 of 4/5. That's what I put in there for x. Plus alpha trace, there should be 5 of them, y1 of 6/5 plus alpha trace y1 of 8/5. Oops, wrong size right there. Plus alpha trace, and you can type in 10/5, but I'm just going to put 2 for this one. Chop, why didn't you do it on the paper? Because we're looking for a pattern on the paper one. So I got 16.2. And when I multiply it by 2/5, let's see, times 2/5, I get 6.48. I don't see any issues at the moment. It looks good to me. Does it look good to you? I make mistakes all the time, so let me know. Okay. All right, here we go. We're going to see if we can come up with a sigma notation formula. So remember, n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. I think we can figure out the 2/5 one pretty easily. So I'm going to go ahead and put it like this and put something in parentheses with a 2/5. And I can see there's a 5 in each one. Do you see that 5 on each one? I put a minus there. How come you guys didn't tell me that I put a minus there? So I see a plus 5 on each one. Have I lost anyone? Yeah, it can be easy, but it can also be hard. So far there's a 2/5, so there's my 2/5. That plus 5 is that plus 5. So notice, when n is 1, I got 2/5. When n is 2, I got 4/5. When n is 3, I got 6/5. So what can I put? So, and I see that negative in the outside, so I'm going to put negative and parenthesis right here, and I'm going to put squared. And I'm going to say n equals 1 all the way to 5. So when n equals 1, I need it to be 2/5. When n equals 2, I need it to be 4/5. So what can I put in here? Yeah, I already used n, too bad. What can I put in here? Yeah, 2n over 5. Yeah, that will work. That will work. And there it is. Let's check to see if this works. So if I check my calculator, I'm going to go math. I'm going to go summation. I'm going to put x equals 1 to 5. I'm going to go to this one, and I'm going to put, open up a parenthesis, and I'm going to put negative. Open up another parenthesis, and I'm going to put, what am I going to put? X, 2x. 2x over 5. Move to the right, close it, put a square on it, plus 5. Close that parenthesis. I think so far I got everything correct. Open parenthesis, and then 2/5. Let's see. Oh. Okay, let's see if that is really that same number. Decimal. There it is, guys. We got it. All right. Yeah, practice. The next move, we need to make sure. What's going on, Miss Cruz? USB charger way in the back. I don't know, Miss. I have a really USB charger back there. All right, here we go. We're gonna have to eventually be able to do summation notation with function notation, which f of x. So f of x, I'm gonna right here on the side. F of x was negative x squared plus 5. So let's see if we can do it with this. So sum. We can still use n. N equals 1 to 5, and then we can say f of. So remember, this was my x value, x value, x value, x value, x value. So that means I can write 2n over 5 inside of that. That's my height, and then times my width, times 2/5. And that should also give you the correct answer as well. I don't see any issues. Let me know if you guys do. Let's test it. So here we go. Math, number 0. So we already got that down. X. Remember, we already have it in our calculator, the function, right? To 1. And I'm going to push alpha trace y1 of parenthesis. I'm going to put it with the fraction feature. And what did I put in there? 2n or 2? Yeah, 2n over 5. So I'm going to put 2n. Yeah, ask me. Because I make mistakes all the time. And then close it. So there it is. That's my f of x times 2/5. Yes, ask. Why did I put y1? Oh, yeah. It needs to be a 5. Thank you, miss. I didn't do that on purpose. It was an accident. I had enough copies, so. All right. So there it is. I think everything's correct now. This is like your height, the y1, and the 2/5 is your delta x. Width times height. And I'm just adding them all up. Enter. And look at that. If you understood that, you've already jumped a big hurdle. Cool, right? Okay. So we're good. This will also give you 6.48. Okay, see if you can leave. Oh, I didn't leave any room. Okay. I'll put it right here. All right, guys. You know what? I was not gonna do this until the very end, but I think right now that we got this down right now. All right. So then I think it's best if I introduce it right now before we go into harder stuff right now. All right. How do I make this a better approximation? Put more rectangles, yeah? Right? All right. Here's the question, and I think I kind of already cheated because I think I told it to you last time, but maybe you remember, maybe you're not. How do I get the exact area under this curve? I'll put how many rectangles? Starts with the letter I. An infinite amount. So how do you tell it to give me an infinite amount of rectangles like this, guys? Look, check it out. So just don't write anything down. Just listen and tell me if it makes sense. So I'm going to write limit. And what letter have we been using for rectangles? N. So I'm going to write as n approaches infinity. And I'm going to start. All right, guys, focus. I need your A game. Don't write this down. Just listen to take this in. I'm going to start at my first rectangle. Now, I already used the letter N. I got to use a different letter. So usually you use I, J, or K. Which one is your favorite from those three? Okay, I, J. It doesn't matter. All three of those are very common.
No J's. I.
Okay, K, because no one said K.
No J's.
K is 1, all the way to the nth rectangle. Now remember, what is n approaching? Infinity. And then let's see, which one should we do first? Let's do this one. I'm going to type negative, parenthesis. Now remember, look, we started with the kth rectangle. So I'm going to write 2k over, how many rectangles do I have? In this one, I had 5 rectangles. On this one, yeah, I think I heard you say correct. I have how many? So I put n in the bottom. See? 2k over n, and then I close it with a squared, and then I put plus 5. And then I'm going to put a parenthesis on all that. So there it is. That's going to give me the height of each rectangle, and I need to multiply by the delta x. Now again, how many rectangles do I have? So remember, look how we got delta x. We got it by doing upper minus lower divided by number of rectangles. So I'm going to write 2 over, and I'm not going to write the number 5. I'm going to write what letter? N. And there it is. That's how you write the sigma notation for the perfect area under that curve. Did that make sense? Okay, it didn't make sense. What didn't make sense, Konduru? Yeah, for you just walked in. Oh. All right, tell me, Ro, did everything make sense?
Yes.
Okay. Tell me, Denise, I want you to ask me. Put in your notes. That this is the perfect area. Yeah, perfect area, exact area. I guess perfect is, put the word exact instead of perfect. Exact area. Exact area into the curve from 0 to 2. All right. So I'm a little scared, but I'm not sure we should. Okay. Let's see if we can do this one. Oh. Yeah. I'm giving you time. There it is. All right. Here we go, guys. On this one, all right, guys, focus. So we're doing the same thing, but this time with RRAM. So draw a grid. We're doing the same thing, guys. Your delta x is still 2 minus 0 divided by 5, because there's 5 rectangles. They want me to do that. So let's see. First rectangle, second rectangle, third rectangle, fourth rectangle. 1, 2, 3, 4, 5. Okay, there it is, 5. All right. So this one is 2/5, 4/5, 6/5, 8/5, and then this is again 10/5, which is 2. And I'm using RRAM. So it's going to be a slight over approximation. So here it is. It's the same curve. N equals 1.
What?
All right. We're doing the same thing, guys. I'm going to try really hard. All I'm doing is width times height. The width of each rectangle is still 2/5. 2/5. And now the height is dictated by the leftmost point. So negative parentheses 0 squared plus 5. I'm going to show that. Plus 2/5 parentheses negative parentheses 2/5 squared plus 5 plus 2/5 negative parentheses 4/5 squared plus 5 plus 2/5 negative parentheses 6/5 squared plus 5 plus 2/5 negative parentheses 8/5 squared plus 5 plus 2/5 parentheses negative 10/5 squared plus 5. Oh, you're right. I did an extra. Thank you, miss. I would have been totally wrong. Because the last one is the 8/5. You don't use the 2. And if I would have caught it right here when I would have been like, oh, I have an extra term. N equals 1, N equals 2, N equals 3, N equals 4, and N equals 5. Those are my 5 rectangles. Take your calculator. Well, I guess let's go ahead and simplify it. So I'm going to go 2/5 is in every single one because that's your delta x there. So I'm going to write 2/5 parenthesis, and then I'm going to sum all these up. So I'm going to take my calculator, and I already have it in y1. So I'm going to go alpha trace y1 at 0 plus alpha trace y1 2/5. I'll make sure not to do the 2 there. Plus alpha trace y1. Make sure you practice, guys. y1 4/5 plus alpha trace y1 6/5 plus alpha trace y1 8/5. There's my last one here. If I did everything correctly, I got 20.2. And I'm going to multiply by 2/5, which is the same thing as 0.4, times. And 8.08. That sounds like a song. 8.08. The Players Club or something like that. No? 808. There it is. I knew it came from somewhere. Okay. Are we okay? All right. So we have the same job as last time. Let's come out with a sigma notation that will give us this. So let's see. I'm going to write sigma sum from n equals 1 to 5. There's 5 rectangles. And I see a 2/5 on all of them. And you could put it in the front, but it's common, not common courtesy, but we usually put it in the back. But it could be in the front, the 2/5. All right. Negative parenthesis something squared plus 5. All right. When we did RRAM, we said 2n over 5. This one is going to have what in the top? Obviously, I see a 5 in the bottom of all of them, right? So now my numerator, so I'm still going to have a 2n, because obviously this one's 2, 4, 6. But how do I get a 0 on the first one, though? 2 parenthesis n minus 1? 1 minus 1 is 0, right? All these, see how it's 2, 4, 6, 8? So I still know that I'm doing this. I'm still multiplying by 2. But then I want to zero out the first one. And if I'm only away, I know 0 times anything is 0. So I'm like, oh, okay, so n minus 1. Does that make sense? Yeah, and I know when it's your first rodeo, it's hard, guys. This is why right now, this is your first rodeo. It's hard. But once, like for you future engineers, this is going to be cake for you guys because it's going to be like, right now it's your first rodeo. But once you've done this 3-4 times, it's no longer your first rodeo. All right, so there it is. I think we got it right. If I plug in a 1, I get a 0. If I plug in a 2, I get 2 minus 1 is 1. 1 times 2 is 2. If I plug in a 3, 3 minus 1 is 2. 2 times 2 is 4. Perfect. It looks like it's working. Do you guys see that? Cool or not cool? All right. Now check it out. Here's the question. We'll make it easy for you. Which one of these two, the LRAM or the RRAM, did you find personally easier to create a model, to create this? So that's what we're going to be working with, RRAM. I'm not saying you can't do it with LRAM. You can. It's easier because we don't have to take into account that n minus 1. All right, here we go, guys. So when you go to this, relax, relax, relax. All this is saying, all right, guys, relax. All this is saying is that you have a case rectangle, and they're just counting. First rectangle, second rectangle, third rectangle, fourth rectangle. Obviously, these have different, yeah. Don't worry. That's all it's saying. You have some positive, you have some negative. This is signed area. All you're doing, I'm going to help you out, guys. Label this. This is your height. This is your width. Is that how you find area of a rectangle? Then you're good. That's what you're adding up, an infinite amount. So look what this says. This is your height. This is your width. And then all you're doing is adding out an infinite. So adding infinite amount of rectangles. Cool or not cool? Where K is just the case rectangle. I know it says some interval. I'm going to write case rectangle. The first, the second, the third, the fourth, the fifth. Keeps on going forever until you get to the nth rectangle, which remember, n approaches infinity. Nothing crazy, right? All right, we're going to make a statement. Go to the next page. And don't worry, you're going to learn this fundamental theorem of calculus tomorrow when we cover it. We're going to cover it in class. So here it is. Look how this is. All you're going to do is practice making this statement. Okay, I'm going to go slow. This right here. All right, guys, focus. This right here means exact area under the curve. Infinite rectangles. I think everyone's okay with that. Remember, n is rectangles. N approaches infinity means we have infinite rectangles. Does that make sense? And we just talked about what that means. If we want to remember, look, this is your height. This is your height. This is your width. And all they're telling you is you see all these symbols here? You can make it look like this expression. This is an elongated S. It stands for like sum. So I'm going to write elongated S, quote unquote, quote. And it stands for sum. What does it mean? It means an infinite amount. You're adding an infinite amount of rectangles. So it means exact area as well. Exact area from x equals A to x equals B. So this is your start. The x value for your start, x value start. And this is your x value end. I'll give you a visual. Don't worry. I'll give you a visual. So here's your visual. Ready? Integral a to b of f of x dx. That dx really means delta x. See? Equals, here's my graph. That's f of x. Here's a. Here's b. It's that area. The exact area. Chop, why does that mean that? Well, all we're doing is just taking this that we just wrote on the left-hand side and turning it into an integral. That is called a definite integral as well, but we're not there yet. We will do the fundamental theorem of calculus tomorrow. Yeah, bring your A game tomorrow too. Okay, ready? All right. Don't worry, you're not gonna be calculating the areas right now. All you're gonna be doing is figuring out this and turning it into that. That's all you're doing. Going from the left to the right. And we have some nice activities for you. Then we just talk about the dummy variables. It doesn't matter what you call it. Don't worry, you can read that later on. It's not necessarily detrimental to us right now. Okay. Don't worry, we're gonna go slow. We're gonna go slow, guys. Don't worry. All right. The interval -1 to 3 is partitioned into n subintervals of equal length, and delta x is equal to 4 over n. Let m of k denote the midpoint of the k subinterval. Okay, underline that, and you're just going to go, it's just some x value. Some x value. Express the limit as n approaches infinity from k equals 1 to n of 3 m's of k squared minus 2 m's of k plus 5 times 4 of n as an integral. Child, what's an integral? This is what we just did. Yeah, focus, guys. Focus. This is an integral. So they want you to show the sigma notation to an integral notation. Relax. You don't have to worry. It's going to be pretty simple. All right. So I can tell that this right here is your function. That's your f of x. That's your quote unquote height. And this is your width. Are we still okay? Where am I starting when I find my area under the curve? What's my first x value? Positive or negative? Nice. What? What's my first? So I'm going to write integral. And you're going to put -1. That's your start. The x value start. And where do I end? So I'm going to put a 3 right here. That's your end. Are we still okay? All right, so I know, Chop, what are you doing? I have no idea what you're doing. I'm doing this. A to b, f of x, dx. That's what I want. This is my function. This is my function, guys. What did I tell you about m of k? It's just what? Look what it says up here. It's just what? Some what value? So I can just rewrite this as 3x squared. That's just some x value. Minus, what was m of k? Some x value. So just 2x plus 5. That's your f of x. And usually you want to put parentheses on it, but some textbooks have a bad habit. They don't put the parentheses. Not a big deal. That's your height. And I need to multiply that by my width, which is dx. That's delta x. Done. That's it. That's all they wanted on that. Delta x was 4 over n. Yeah. Those are easy. I think to go from integral to go from sigma notation to integral is easy, but going the other way around, I think that's the harder part. So relax. I'm gonna break it down for you. Really simple. Okay, ready? So all this was write a limit using sigma. Write a limit using sigma. You can't even talk. Write a limit using summations that would equal this. All right. Remember, guys. This means exact area. So you're using infinite amount of rectangles. So all your limits are going to start the same. Limit as what approaches what? All of them should start the same all the time, forever and ever. I'm going to put sigma. And then what letter do you want to use? I, J, or K? It does not matter. I. For I equals 1. No, I looks like a 1. Let's use K. Because I and J have that little dot on them, and it looks like it could. So from K equals 1 all the way to N. I want an infinite amount of rectangles. All right, here's my function. So I see the 4 and I see this 4. So I'm going to put parenthesis. And I know that I need a 4 over something. Bless you. Plus 4, close it. And I know that I need a delta x. So I'm going to put delta x right here. All right. Here we go. I need your A game right here, guys. I'm going to go to the side. I'm going to write delta x. How do I get my delta x? Upper minus lower divided by number of rectangles. That's how you always get delta x. In statistics and algebra 1, and upper minus lower divided by number of rectangles. That's how you're going to get the width of each rectangle. So upper, what's my upper limit? 7 minus the lower limit, 4. So that's my change in x. And for each rectangle, I know it says your delta x there. I have to divide by the number of rectangles. How many rectangles do I have? N. So 7 minus 4 is, so 3 over n. That's what goes right here. All right, how do I figure out? Remember, guys, you see this right there? That's just an x value, right? Some x value. Okay, so I'm going to write x, and I'm going to put the subscript k. Relax. That just means the x value of your k's rectangle. Yay or nay? Okay, equals. So let's go back and reference my picture here. You know what? I should have started somewhere besides 0. That's fine. How did I get this x value here? No, relax. It's not even that bad, miss. Look, it's just my reference point, 0, and all I did was, isn't this gap just your delta x? So here it is. Where did I start? I started at, and next time I'm going to change it from starting at 0. I started at 4, so I'm going to write 4. And I add my delta x. And then I got to multiply by what? Okay, and I'm going to slow down. That's only how you get the first x value. It depends on what rectangle you are in. That was my first rectangle. Now notice my fourth, okay, what if I'm right here and n equals 2? I need to go from the reference all the way to here. So that's 2 delta x's. What if I go to 3? From here all the way, what if I want this x value? That's 3 delta x's. Do you see what we're doing here, guys? So my first rectangle, my second rectangle, my third rectangle, my kth rectangle. Does that make sense? So over here, and I hope that made sense. I'll repeat it if I have to. I'm gonna go times my kth rectangle, because that will tell me what my x value is. Does that make sense? So look at this. 4 plus what was delta x? 3 over n times k. So you can write it as 4 plus 3k over n. And that will tell you the x value for your whatever k's rectangle you have. Does that make sense or no? Okay, I'm going to start again. Let me go over here. Guys, focus really hard on this because this is the hard part. You can be a robot. There's obvious pattern. You can be a robot, but I don't want you to, because if you're a robot, you're only going to be good for now. And then when the AP exam comes, you're going to get it wrong because you were a robot and forgot. But if you know the concepts, you'll never get it wrong. Look, and I'm sorry, guys. Next time I'm going to start it at like a 2 or some different value. If I want this x value, I have to go 2 delta x's from my original because I'm referencing my original. My x of k, I'm referencing the 4 where I started. If I want this x value, I have to go 3 delta x's. This is my, I know we're using n, but remember, n is infinity. This is my first rectangle, my second rectangle, my third, my kth rectangle. All the way, because we started at k equals 1. That's my first rectangle, second rectangle. So if I want this x value here, my reference plus 4 delta x's. So, does that make sense? So times 4, because that's your kth rectangle, times your kth rectangle. So that's how we came up, and it's always going to be like that. Always, always, always. So you're going to see, it's going to get easier. So there it is. So this is always going to be like that. It's always going to be your lower end. I guess we can start it like we can make a formula. A plus k times delta x. There's your formula, guys. A plus k times delta x. And that's how you find your x value for any rectangle, any kth rectangle. So I'm going to come over here. Chop, what's A? This one right here, integral a to b. That's A. All right, so here we go. I'm going to write 4 plus 3k over n. And there it is. That's my formula for that one. And that's it. Don't worry, we're going to do more so you can practice. All right. Here. Yeah, look, we're going to do a whole bunch so you can practice. Look. There's a whole bunch. So we're going to practice here. All right, what do I do first? It wants me to do the same thing. So I'm going to write limit as n approaches infinity, sigma notation. We're using letter K. I'm going to start at the first one, and I'm going to go all the way to n. And now that just says x squared, so I'm just going to go parenthesis, put a square on the outside. That's just some x value. I'm going to go to the side, and I'm going to write, okay, delta x. This is my delta. I need another parenthesis right here. That's my delta x. Delta x, upper minus lower. So what am I going to write? 6 minus 1 divided by n. What's 6 minus 1? So 5 over n. Put the 5 over n in that parenthesis right there. All right, how do I figure out what's going to go in here? That's just some x value. So here's my x value for the case rectangle. What's my lower limit? 1 plus, what's your delta x? 5 over n, and I got to multiply that by my kth rectangle. So this is going to look like this. 1 plus 5k over n. That's what goes in here. 1 plus 5k over n. That will give you the x value for any kth rectangle. Does that make sense? Yeah. All right, that's it. That's it. You're done. See? Let's go to the next one. What do you want me to do first? The limit stuff, or do you want me to write the x of k and all that first? Okay. Limit as n approaches what? Infinity. What do I write next? Sigma from k equals 1 all the way to n. And then let's see, this says square root, so I'm going to write square root. I'm going to put something inside that square root. So, and I need a delta x as well, so parenthesis like that. All right, I'm going to come to the side. I'm going to write delta x. Upper minus lower. So what am I going to write? 2 minus 1 divided by n. So what do I get? 1 over n. Now I need my x value. So x of k equals, what's my lower limit? 1 plus my delta x, which is times what? So my final x of k looks like this. 1 plus k over n. So that's what I'm going to write in here. 1 plus k over n. And in that parenthesis that I have there, 1 over n. There it is. You did it, guys. You're doing it. Cool or not cool? All right, let's go to the next one. So limit as n approaches infinity, sigma notation for k equals 1 all the way to n, ln, open parenthesis, close parenthesis, and then open, close. That's your delta x. I'm going to go to the side. I write delta x equals, what do I write? 6 minus 4 divided by n. What's 6 minus 4? So 2 over n is your delta x. So there it is. I'm going to put that in there. And then your x of k. X of k. What's my lower limit? 4 plus 2 over n times k. So 4 plus 2k over n will tell you any x value. So wherever you see x, that's where you plug it in. 4 plus 2k over n. Yeah, all these are indicative of which one? LRAM or RRAM? RRAM. These are all RRAM, guys. All of these. All right, next one. Oh, Chop, this one goes backwards. That's fine. Not a big deal. Delta x equals upper minus lower. So I'm going to go 5 minus 7 over n. Yeah, I know. I went out of order. I should have done my limit here. Limit n approaches infinity of sigma from k equals 1 to n, parenthesis 3, open parenthesis, close parenthesis. I'm going to put something in there. Plus 1, close, times your delta x, open, close. So it looks I already have my delta x. It is negative 2 over n. Negative 2 over n. X of k. What's my lower limit? 7. And I'm obviously, you can write minus if you want, but I like to put plus to keep it consistent. Plus the negative 2 over n times the k. So x of k is 7 minus 2k over n. 7 minus 2k. There it is. Is this getting easy, guys? Perhaps. All right, limit as n approaches infinity, sigma from k equals 1 all the way to n. Giant parenthesis, 4 little parenthesis. I'm going to write something inside that little parenthesis. Plus 2, close it. That's your f of x. That's your height. Times your delta x. So I'm going to go to the side. And I'm going to write delta x equals upper minus lower. 3 minus 1 divided by a number of rectangles. 2 over n. My x of k. My lower limit, what is it? 1 plus 2 over n times the k. 1 plus 2k over n. So that's going to go right here. 1 plus 2k over n. And then your 2 over n right there. Oh, I forgot the square. Yeah, it won't be correct if I don't put the square. And there it is. How do we feel, guys? All right, we have a little activity. Don't worry. I have it right here on paper. It's in paper. It's a matching. No, it's going to be simple. Here, you want to pass them up? You look like you need a break. Now, we'll do a few together just in case.
Do we need to show our work on here?
No, we'll do some together right now, just to get you guys started. All right, guys. You only have 10 questions in here. You're going to finish it really fast because it's not that bad. In a little bit, I'll put a delta so you can practice. All right. You guys ready? You guys ready? Try and do as much as you can on your own. If you that way you can get used to it. All right. So let's look at number 1. So I'm looking at it and I can see I have an upper limit of 3, a lower limit of 1. So your delta x on that one is going to be 3 minus 1 divided by n. So 2 over n. Do you guys see that? So, and then of course I start at 4. So I better see something like limit as n approaches infinity, sigma summation from k. What does she use? J? From j. This is coming from Dixie Ross. That's her name. J equals 1 to n. 4 parenthesis 1 plus, oh man, am I going too fast? Maybe I should have done that on the side. 4 open, close, plus 2, and then close, close, 2 over n. All right, my x of k, or x of j, the way she wrote it. X of j is, I start at 1, plus my delta x is 2 over n, and then I multiply it by, in this case, j, because she's using the letter j. So in here is 1 plus 2j over n. So let's look for that. Do you see it? It is D. It looks like that to me. Yeah, she doesn't have. I don't think this is coming from Dixie Ross. So let me give her the credit. And I don't think she has software to make it look like the way that the text makes it look. But there it is. It's letter D. Do you see how we did it, guys? All right. See how many of these you can do on your own, and then you can use your friend as a reference. But try to do them on your own initially, and then I'll put some on Delta so you can see what's up. All right. This is coming from Delta. There's a guided one and there's an unguided one. So look what it says. I'm going to get it wrong on purpose here. Let F be the function graph below. If 20 subintervals of equal length are used, write a summation that would represent a right Raman sum approximation of. And there's a reason why they tell you right Raman sum, because that's the easier one. So look, I'm going to get it wrong on purpose. I know that it's 20 because it says there's 20, but I'm going to put 25. And let's just pretend 0 plus 1 over k. It is all wrong, guys. All wrong. 1/5. Try. Yeah, see, look, all wrong. And yeah, see, your summation is not correct. Keep trying. See, so this is why it's guided. Okay, so let me start. Let me reset. There should be a reset button. Okay. How many rectangles do they want? 20. So you're going to go from k equals 1 to 20. And then here, what are you going to type in here? This is in function notation, f of x. So we're going to type, you start at 0, and we're using the upper limit is 1 and the lower limit is 1. So I guess the delta x is easier to do. So delta x, 1 minus 0 divided by 20. So 1 over 20. Do you guys see what we did there? And then in here, what am I going to type? Well, I started at 0 and plus each case rectangle, the first rectangle, so it's delta x times your k. So I'm going to write k over 20. And there it is. Because n is this doesn't have the limit as n approaches infinity. Let's see if it does though. I'm gonna push try. And let's see, it does it again for me. And look, there it is. And then submit. Where's the infinity ones? Let me see if they give me an infinity one. Oh, all these are okay. Let me look at the other one. Right integrals of okay, this one. There we go. This is better. I like this one better. Write a limit using summation that would equal this. Relax. Look, I start at 0, so I'm going to write e and then the e to the power. And then up here, I'm going to go 0 plus. So what's my delta x? 2 divided by 2 divided by n. Yeah, because n is the number of rectangles I have. And then multiply that by your case rectangle. So I'm going to go, and I put x there. I'm going to put 0 plus, you don't have to put the 0, by the way, 2 over n times k. So 2k over n. And there it is. I don't see any issues. I think it's correct. Let's push submit. And yes. And there it is, guys. See? It actually has pretty good notes on this one. K times delta x. That's what we did. What do you guys think? Not bad, right? So that's it, guys. Show me your handout, the matching activity. Just show it to me, and I'll put the 100. And then just take care of the delta for practice, and we're done.